Let's simplify a complex fraction that is not in the form of a single fraction over a single fraction like the previous work we were doing. Those were easy. Okay, so here's an example of a complex fraction that's more complicated than a single fraction over a single fraction. In the numerator, we have x plus 6 over x squared minus 9. Now, that's a single fraction, but look what's on the bottom of this big fraction. X over x minus 3 minus x plus 4 over x minus 3. Okay, so this is very difficult. It's not a single fraction over a single fraction. So the way we do this, step 1, we take the LCD of all the baby fractions. Okay, the baby fractions here, the denominators would be x squared minus 9, which is x plus 3 times x minus 3. And then there's an x minus 3 downstairs and an x plus 3 downstairs. So the LCD of just the little fractions is equal to x plus 3 times x minus 3. Okay, what do we do with the LCD of all the baby fractions? Step 2, write the original problem. On the top, x plus 6 over the factored x plus 3 times x minus 3. All of that over the bottom, which is x over x minus 3 minus x plus 4, in parentheses, over x plus 3. Okay, what are we going to do with this? We're going to multiply the top and the bottom by the LCD of all the baby fractions. So x plus 3 times x minus 3 multiplies the top over x plus 3 times x minus 3 multiplies the bottom. Okay, now it's legal to do that because all I did was multiply the original question by this fraction that's the same as 1 because it has the same thing on the top and bottom. Okay, let's distribute the multiplication across the top and across the bottom. Across the top, and there are two terms separated by that minus sign across the bottom. Now let's simplify this. On the top we have our original x plus 6, now we have times x plus 3 times x minus 3 over the original x plus 3 times x minus 3. Now just hold on. Do you see where that came from? I took the LCD and multiplied that top fraction by that LCD, x plus 3 times x minus 3. It only multiplies on the top because really the LCD, x plus 3 times x minus 3 on top, it's really like it's over 1. So it's just multiplying on the top. And it's going to do the same thing on the bottom to those two terms separated by that minus sign. Just multiply the top. X over x minus 3. And on the top we have x plus 3 times x minus 3, then the minus sign. Then we have our parenthesis x plus 4 times the LCD over the original x plus 3. Now, go through each of these, the top and the two terms on the bottom, and cancel any common little factors. Let's see, the x plus 3, the x minus 3s, and what's left? No more baby fractions. This got rid of all the baby fractions. X plus 6 on the top over x times x plus 3 minus parenthesis x plus 4 times x minus 3. It's always going to happen. When you multiply the top and across the bottom with the LCD of all the baby fractions, the little denominators are going to disappear, and you'll just have a regular fraction when you get to step 4. Now, let's get rid of the parentheses on the bottom. Let's see, x squared plus 3x minus bracket. Foil that, but use the bracket to remind yourself you need to distribute the negative sign. X plus 6 on the top, and then x squared plus 3x minus x squared plus 3x minus 4x plus 12 simplifies the x plus 6 on the top over 2x plus 12. Now we can factor the bottom. 2 times x plus 6 factors on the bottom because we have 2x plus 12. So we have 2 times x plus 6 on the bottom. The x plus 6 cancels, so we're left with a 1 on the top over 2 on the bottom, and our fraction is simplified. The moral of that story is that when you have a complex fraction, in other words, baby fractions embedded in a large fraction, and it's not of the form of single fraction over a single fraction, the fastest way I know to simplify it is to multiply across the top with the LCD of the baby fractions and across the bottom. Then all the little denominators disappear and you have a regular fraction. There are other ways to do this, so if you have another way, that's good. Use it. I just think this one's fastest. It's up to you how you want to do it.